So inheritance is another concept. What does inheritance mean? Sketch Java, just an English word. What inheritance means? What do you mean by when someone is inheriting something, getting something from parents? Or not Java. Just when I say that you're inheriting something from your parents, what does it mean? Because yeah, you're sharing something, right? You're sharing something. That is what it translates in Java. When you say it has an inheritance relationship, nothing but it is a kind of relationship between two classes, right? So one class shares the code of another class. The way it shapes and the rules are different. There are many ways of sharing and all those kind of things. I'll talk about all those things. So what is inheritance? It's a relationship between classes, right?
Hello, sir. Okay, can you hear me?
Hello?
Sir, we are unable to hear you.
Extends family, right? So now, what does a newborn have? Yeah, a string first name. Yeah, guys, again, let's just have two constructors and stuff here. And then a method to display those things. Okay, guys, one class and then a constructor and a method. Okay. Right, in the next class, I'm extending family, and this class has its own variable called first name, and then I'll have a constructor here as well. Right, and then a method. Right. So let's create objects of both the classes, class family and class name. So family f equal to new family, and then last name John. I don't know if it's last name. 256562, and then f dot display happen here. Oh. So yeah, then we'll have a next object of a second class. Newborn will equal to new born, and then just the first name, right? So now so yeah, let's just run this program. You see this? So the thing you want to focus on this thing, this example is that I have two classes which have a relationship between them that is nothing but inheritance. So this class is being extended by this newborn class. So whatever is present in here, okay, forget the constructors, except the constructors. It has these variables. And this method. Okay, so this is how it looks like. Once you extend a different class, this is how it looks like. All the non-private members of this class, virtually or physically, whatever it is, it's present in this class. So you can just directly access those things. Okay. So now the question is, again, forget the question. The thing is, there's actually a kind of terminology they use when they're referring to inheritance. This is called as subclass, and this is called as superclass. Okay, whichever class is extending is called as subclass, and the class which is being extended is called as superclass. Or you can also say parent class, child class. Again, there's just too many variations for that. And one more thing you have to know here is, do you see this display method here? Now, what I want to do is I also want to name this method as display, because see, now display is fine and then show is fine. If I have another class, then what should I come up with a different name? It just gets, no sooner I'll be running out of names, right? Because all those methods do the same thing. They print something. So why not just have display method? Will that be a problem? It won't. Why? This is nothing but polymorphism. What polymorphism in Java says is a method can have more than one method can have the same name. Okay. Now this is not method overloading. This is actually method overriding. What is method overriding? I'll tell you what it is. See, I've said you right. Once this class has extended a parent class, all the non-private members present here are also present here, right? Because this is inheritance, right? So now there are two display methods here, the display method from the superclass and the display method of this class. Even though the spelling is screwed up, there are two display methods here, right? So now when I'm calling display method here, okay, now see, because I'm calling display method of newborn object, so it goes back to this class and looks for a display method. It finds two display methods. One display method is from that superclass, and one display method is of this class. So now which display method will be called? This is called as method overriding. Always when you have such kind of conflict, always the local method will override the foreign method. So that means the subclasses members will always override the superclasses method. So even though there are two display methods, it always prefers the local display method. So this will override that display. This is nothing but method overriding. So according to this is called as runtime polymorphism or dynamic polymorphism, because what happens here, or what polymorphism, what method overriding says is a subclass and a superclass, if it has two methods with the same name, then always the subclass's method will override the superclass's method. That is how it works. So that is one thing. Now, what if you want to call this display method from this method? How would you do? You want this method, because see, this method, display method, is by default present here, right? So you want to call display method in this display method. The display method of the super class should be called in the display method of this class. Why do I want to do? Because that way, if I only call this method, both the statements will be printed, right? See, when I do something like this, display, what happens here when I do something like this? So what I actually, the reason I wrote display method, or the reason behind me writing the line number 32 is, I thought that when I'm calling display method using b, when I'm calling b.display, instead of just printing first name, I also want to print last name and apartment number. So this thing is being printed by the display method of this class. So I just wrote display method. Let's see what happens when I try to run the program. See, it just keeps on growing. I think this console might have ended, but it just keeps on going. This is called a stack overflow exception, if I'm not wrong. Yeah, stack overflow error. The thing is, what exactly is happening is, again, I've told you, even though there are two methods of the same name, this display method, you thought that this display method will be called by this thing, but I've told you, local will always override the superclass. So the way this thing is working is, exactly, it just keeps calling itself. You're calling display, and the first statement will call display. So again, with control, we'll go to 31, 32. It's just a loop. It's just an infinite loop. The stack just goes around, around, around until it runs out of the memory, and then it gives you the error. Stack Overflow. Stack is nothing but where your call stacks go into place, right? That is how it goes. I'll explain you what a call stack is. But this is what is happening right now. So how would you differentiate, or how would you tell JVM that, hey, when I'm saying display, I'm not saying call display method of this class, but I want to call the display method of the super class. Is there a way of telling this to the JVM? Yes, there is. There is something called as super keyword.
Super.
Okay. By using super keyword, you can always refer to the members of its super class. So when you want to say that, hey JVM, this display method is the display method of super class, you say that by just writing super dot display. That's it. When you do this, it works, right? This is how it is. So now super can also be used in a constructor also. For example, in a constructor, let me show you how it is used in a constructor. Let me just say that Mike, and I also want to pass using this constructor of newborn class. I want to initialize these two variables also. So I want to do 258. Sorry, and then I want to say some last name, right? I want to say Hunt. Okay. So now, what happens? The JVM enters into main function. It sees 41 lines, 42 lines, it's fine, and then it comes across 44th line. What happens is, again, it sees, okay, I have to create an object of this class newborn. It sees this constructor, newborn constructor that has 3 parameters. So it goes back to newborn class. It keeps checking for a constructor that has 3 parameters. So is there there's only one constructor and that doesn't have any parameters. So what would you do? Let's have a constructor which actually has 3 parameters. So the way you do is public newborn string f name, and then with the other thing, apartment number, right? So int a, and then string last name, right? So now, fine. Now how would you initialize? Because you see this a, apartment number and last name are the variables of super class, and who assigns these two variables? Super class is constructor. This is the constructor, right? So now how do you call this constructor in this? Just like the way you called the display method of super class, the same way you call the constructor of the super class also. What you do is you just write super and then just provide here whatever it is. You say A and L. Right? That is, so what happens here is it passes those two values. When you're just saying super, implicitly the super constructor gets called, and then in those apartment number and last name of these class will be assigned. You understood what a super keyword does? So see, of all this discussion, one thing you have to remember about super keyword is super keyword always refers to the members of the super class. Doesn't matter if you want to access variables, methods, or constructors. If you specifically or if you explicitly want to address members of superclass, you use super keyword, right? And one more thing you learned here is what method overriding, which is a feature of polymorphism. Again, there are two types of polymorphism: runtime, compile time. This method overriding is actually runtime. I'll tell you what compile time polymorphism is in a minute, but let me finish this thing. So what do you think? Which kind of inheritance is this? Which kind of inheritance is this? We have discussed 4 types here, right?
Single.
Single, multi, exactly, single inheritance. So a single inheritance is nothing but you have a class which extends another class. That's it. That's the end of it. Just relationship between 2 classes of single inheritance. Now what is a multi-level inheritance? Multi-level inheritance is you have a class A, okay, and then you write a class A, class B which extends A, okay, and then you have a class C that extends B. So it's like a chain, right? So this is nothing but multi-level. More than 2. That is what it is, multi-level. So this class come. Any questions about this inheritance, single inheritance? This is probably the easiest of all the four. Yeah. All the inheritance classes? No, it can be in different packages. It all depends on the modifier that you're using for the class. If it's public, then you can access it from anywhere. It doesn't matter. If you're writing, and always remember, a class cannot obviously have a private modifier. You cannot have a private modifier. And it is actually, I think this is a good instance to explain what are the different types of access specifiers. How many different types of access specifiers do we have?
Public,
right? What are
private.
Protected. Okay, there's one more. Exactly. There's one more thing. I'll come to that.
Static.
No, static is not an access specifier.
Yeah, it's default.
Exactly. So let's just see what public access specifier. We have been using public since day one, right? So public means exactly it's just extrovert class. It just exposes itself to everyone, right? Any class you can access from whatever package, doesn't matter. Private is exactly opposite to public. If you declare a class, or if you declare, you cannot declare a class as private. Okay, try doing that. It will give you an error. For a specific purpose. Protected, if you declare something as protected, that can be SE. For example, I see what happens if I say, what happens if I do this as public, then everyone can see my apartment number, right? I don't want to happen that. Now, what happens when I do this? Even the newborn cannot know what the apartment number is. Even, that means even the family member cannot know what the apartment number is. So now, what you want to do is, you don't want the, you don't want it to be public or to be private. But what you want to do is, you don't want the whole world to know, but at least the ones who are connected to you, you can let them know. So there is an access specifier that's the exact kind of thing, where it is protected. So protected. So once you declare a variable of protect as anything as protected, that means it is accessible inside the class and by its subclasses. Okay, so that is the difference between protected, right? Now, the other one which is we never used is called as default access specifier. Now, what is a default access specifier? What does it do? You know what private, public, protected do. What is the default? Just like you said, default is nothing but it's accessible by its own class members and in the same package. All the different classes in the same package. So, do you see this package number? Java. So under this package, no matter if I have 100 classes, all those 100 classes can access the those default variables or whatever it is. Out of this package, if I create one more package, that package won't have access to this. Now, so but we never declared something as default. The thing we never saw default keyword is for an access specifier to be default, you don't have to explicitly say that it's default. You don't do something like this. If you don't provide anything, that is default. So all this time, when you're not writing anything, this means it's nothing but default access specifiers. So this class, default access specifier, right? When you write public, only then it is public, even for the class. If you write as public, then only then it means public. Don't assume when you don't write anything, don't say that that class is public. It's default. Even though you don't see anything, that's the whole point. For a default access specifier, you don't write anything, it's just understood. So those are the 4 access specifiers you have to know. Now, yeah, I was talking about the multiple inheritance. Right? So any questions about single level inheritance and multi-level inheritance? No questions because you have a program about it. So now, do you guys need a break? We've been having breaks, right? Fine. So yeah, guys attending online, can you hear me? The audio is dropped.
We are hearing.
You can hear me, right? And can you see the screen?
I can.
Or it goes again? Awesome. Okay. Yeah. So let's see multiple inheritance. What exactly is multiple inheritance? I'll tell you what multiple inheritance is. You have a class A, okay, and then you have a class B that extends, okay, you have a class B, and then you have a class C that extends A and B, okay, and then you have a class D that extends C. So in this kind of example, for example, consider this. What's happening again? This is not possible in Java. You cannot extend. This is called as multiple inheritance. If a class is extending more than one class, this is called as multiple inheritance. That means it has multiple superclasses or multiple parent classes. This is not possible in Java. Why is this not possible in Java? Because the thing is, the A has some method, B has some method, okay, and same methods. For example, display method here, and when class C is extending both of them, you have two display methods here, right? So fine, you can call a display method superclass the display method with the super keyword. But even though when you say super.display, again it has two superclasses. So which superclass to consider? Again, you kind of can give a solution to that, but it's just this is just the beginning. Things get more complex once you have multiple inheritance. You just get confused, which super belongs to what kind of. So to remove all that confusion, they've altogether removed multiple inheritance. And this problem is actually called as something, it has a cool name actually, I think diamond of the, no internet, wow.
Is and has a relation.
No, that is different, but yeah, I think it's called as diamond of death or deadly death of diamond, something like that. It has a cool name. But the problem is nothing but if you have this is what the problem says. If a class has more than one superclass, then it doesn't know what to extend and what to do from. So they've altogether removed multiple inheritance. Okay. So now the thing is there a way of achieving multiple inheritance? There is a way. I'll tell you what that is, but let me just finish the other concept. You understood what multiple inheritance is, right? So as of now, multiple inheritance is not possible in Java. That is, you have to remember up to this class, okay? Multiple inheritance is not, they don't allow multiple inheritance in Java, okay? Because of the same bad problem. So you're done with encapsulation, right? And then you know what inheritance is. It's just creating relationship between two classes. Again, you only learned what is a relationship is. You also have something called as has a relationship. I'll tell you, not now. And then what is the other thing? Polymorphism, right? So polymorphism, I said there are two types of polymorphism, compile time and run time. What are the other names of that? Method overriding, method overloading. So we know what method overriding is. We have seen that, right? In this example, method overriding. If the superclass, subclass are same method, then subclass will override that thing. So now, we'll see what method overloading is. Okay, it's relatively easier. Yeah, what method overloading does is, for example, you have a class for demo. Okay, so now what you want to do is you want to have a method that adds two numbers. That's it. Okay, int sum, and you say int, and you say int b. And what you do is return a plus b. That is what it does. Now, you decide, okay, what if the user gives three numbers to add? So let's have another method in sum 3 or something. That means sum of three numbers, int a, int b, and then int c. Return a plus b plus c. Right? So this is fine, but the problem is, what if the user can never start, I mean, now I'm doing for 3 variables. What if for 4 variables? I should write another method with a different name, sum4 and all those things. So
Hello, sir.
the thing here, yeah.
You're not able to.
The screen is frozen.
The screen is frozen again?
Yes, sir.
That won't work. Can you see the screen now? No? Cannot see the screen.
No, sir.
Hey guys, can you see the screen now?
Yes.
Yes. Yes.
Yes. It's frustrating. So yeah, again, the point is if I have 3 variables, some method, a different name, and so 4 variables, a different name. So I'll at some point I'll be running out of the names to have different names for each method. So what Java does is it allows you to have the same name for different methods. So instead of just sum3, you can just put sum. That's fine. So for the rest of all the possibilities, you can have the same name, right? So now the question is, when I just write something like this, let me just create an object demo d equal to. I screwed up the naming convention. Yeah, so creating an object and then the 25, 35. No, it does. No, it doesn't. It never gives the error. That is the naming convention. I mean, it's actually a good practice. I mean, that is how it should be written. But yeah, I have written this. See the thing? What's that? No, it's not. See the thing is, if you have seen any of the predefined classes like scanner, right? So how can I say the scanner is a class? So just by looking at it, because I know that in Java, if a keyword is starting by a capital letter, there's a good possibility that it will be a class, right? If I see something in capital letters, all capital letters, I'll say that it is a variable and it is a constant. For example, a pi or something like that. Math pi, not pi, yeah, pi variable. It's pi both a capital, so I can tell that it's a variable and it's a constant because pi is a constant, right? So that's just a naming convention. You can always screw up the name, but it's not a good practice because if you, I've said about that, right? So just make sure you follow the convention, and you also have naming convention for the methods also. So you, again, I'm just afraid the screen will just go again, so I might as well finish early. So yeah. Do you guys any interest left as of this point? I don't know, it just sucks. It just keeps going up and down. Yeah, so again guys, let's just, oh yeah, just let me know. Yeah, guys. So now the question is, I just have this line number 20, right? So when the JVM comes inside the main method and it sees line number 19, it creates an object of the class demo, and then it goes to the line number 20 d.sum. Then our question is, it goes back to this class and it sees there are two methods with the same name. So how does it decide which sum to pick? Just like I've explained in the constructor, same thing here. It enters into this this is signature. It enters into this and it checks. It matches for these things. Here, what it understood, okay, I have to pick a method. If I have to go catch a method called sum, and it has 2 integer variables. So it goes here, and it's like 2 variables. So this has 2 and this has 3, right? So it picks, obviously it picks this one. Now, for example, let's just say double sum. So even in this case, there are 2 variables. So even line number, after the line number 24, JVM goes to this class. It sees there are two methods with the same name sum, and it peeks into this parameter list, and it also again finds two parameters here, two parameters here. So now which one to pick? Now, exactly, it checks the data type. Here it was integers, right? This is not a decimal number. So it checks. I have to pick a method with two parameters that are of type integer. So it will go and pick up this method. So that is how this everything is done during the compilation time. That's why it doesn't throw you an error. So this is compile time polymorphism or whatever it is. So this is what method overloading is. Again, it's just so simple. So polymorphism is this: method overloading and method overriding. Method overriding you have seen in inheritance, right? Yeah.
What if we have float double and float? Your first one is integer, okay? So instead of integer only float, you float sum, float A, float B. And second one is double sum, double A, double B.
Yeah, whatever, you can try n number of possibilities, but always remember, it just which method gets picked, it always depends on the type, the way you're sending the parameter.
If we write another float sum,
Yeah.
float A, float B,
Yeah.
it will.
How can you identify between double and float? Because float will be like 25.5 is double and float both.
Something like this. No, what I'm saying, see, what you're saying is I have, in one case I'll have a double, in one case, try doing that, see what happens. Try doing that, what happens. I don't think there should be a problem because anyhow both the decimal values, I don't think there should be a problem, but just try doing that. As long as your return type matches. See, what happens with the casting is there's something called as narrowing casting, and the other thing is what, widening casting. Yeah, narrowing and widening. So what happens is, do you remember the size of all those data types? Shortest one is wide, short, end, float, double, something like that, right? So you can just, yeah, it automatically casts this way, okay, widening way. So as long as, yeah, as long as you're casting from the larger type to the smaller type, smaller type to the larger type, it doesn't matter because you're anyways adding in numbers, right? So it doesn't matter. So one of those ways is valid. I'm not sure about that, but you might. Good question, actually. Yeah. So out of those two, widening and narrowing, there's one thing that can be done automatically, and there's one thing that should be done explicitly. So I'm not sure about it, but good question. I want to point out that. So you might go and try the different combinations here. 64, yeah. So if you just draw a line, so one is widening and the other way is narrowing. So only one of those ways it can be automatically casted, right? What do I mean by casted is you can have double here and then return in something like that. I'm not sure if it's in double. What I mean to say is that is called as automatic casting. Yeah. So for example, see, I think it's possible here end. And then you have double here. So right now I'm returning a double, right? So if I want to cast this, what I do is I say, see, this is called as explicit casting. To answer your question, this is, along the same lines. I'm taking two double values, a double and float, and when I calculate, I'll get a double value, but I said that I'll be returning an end. So what I do is I convert that double into an end and then return it. So this is called as explicit casting. So you can also, yeah, this is just way. So you just try different combinations. You can just play around with this thing. So this is nothing but method overloading, which allows you to have methods, multiple methods with the same name, but either the number of arguments or the data type of the argument should be different in some other way. Those shouldn't be identical. Shouldn't be like int A and B and C and D. This is a conflict because you'll have two methods with two parameters of same data type. That's just not acceptable. Okay, or at least one of the things should be different. Either the number of parameters should be different, or the data type should be different, or the return type, whatever it is. Again, I ask you to just try different combinations here because you never know. You might end up with some error that cannot. And these are actually frequently asked questions. Method overloading, method overriding. They ask a lot about that because trust me, even I actually look up regularly because you always keep mixing both, or you forget some kind of things in those two concepts. So make sure you dig up this stuff: method overloading, method overriding, the potential interview questions. So yeah, so this was about what? Polymorphism, right? Any questions about this? And any questions about the other one? What was the other one? Inheritance? No. No questions. So now let's have a different you would right here things actually gets interesting. Okay. Abstract class. Okay, that's a bad name actually. No, I just wanted to say abstract example. Just there's no sense to that, but I did the same thing. No, abstract example, right? So yeah. So now the thing, guys, the thing is, what I want to do here is this is the fourth OOP concept called as abstraction. Yeah. Okay. So now what abstractions is? What exactly is abstraction? Again, forget Java. I don't want the these definitions. What do you mean by abstract or an abstract? We all had those abstracts in project reports, right? Like you have to submit the abstract by this deadline. What do they mean by abstract? Exactly, overview of the project, or you won't give the, for example, if you're coming up with an algorithm to solve something, you won't just give away the algorithm, but you will tell what's your approach, what are you trying to solve, and those kind of things, right? That is nothing but an abstraction, just like that. For example, take a car, which is a classic example for abstraction, right? But when you buy a car, if it's the first time that you're ever getting into a car and you go to a dealership and buy a car, all he tells you is how to switch on something, how to turn on the ignition, this is the wheels, this is the controls. He never directly opens up the engine and tells you, you know what, this wire goes up to this thing, when you have to press this thing and all those things, because that's just pointless. This is nothing but that's the implementation. That's the part that the developer of a program or the engineer of a car should understand. We as a client, I mean, we don't bother about how a steering actually connects to the tire, right? All you have to know is when you turn it this way, the tires go this way, but you don't actually go ahead and turn the wheels of the car through your legs or something. That doesn't happen. So just like that in programming, when you write classes, you make sure that the complex implementation is hidden, and you just give just a way to access your program to the client. Okay, you just say what all can you do with this program, but you won't show him how it's done. For example, if it's a program of for example, just a fact, do you know every decimal has a pattern, just a mathematical fact. Every decimal number on this planet has a pattern. See, you have 2.3456 numbers like these, right? The fastest supercomputers, they they keep this keep coming up with the fastest supercomputers. They judge a supercomputer's ability to calculate how more digits of a pi. So until this point, I think we're million billion digits after the decimal point of a pi has been generated, but they still aren't able to find a pattern. So anyways, all this thing just to say that you say that if you come up with you've written your own Java program all through this night. And in that class, you have actually written algorithm or somehow found a way of finding a pattern into a pi value. Okay, you've discovered or you have written an algorithm to find a pattern. But now you want to ship the code, but you don't. But all you want to expose to the client is that you have calculated a pattern or you have found a way to calculate the pattern in pi, but you do not want to expose the algorithm itself. You do not want him to know how you did it. So how do you do that? You do that by exercising this OOP feature, something called as abstraction. You use interface, abstract classes for that. So these are the two words we'll know by this class. I don't think interface we can do it today, but yeah, I'll probably do abstract class and we'll leave interface for the next class. So anyways, abstract class is a class. What is an abstract class? Just a class with which has an abstract keyword declared. That's it. So let me just show you what an abstract class looks like. You have, this is what an abstract class is, right? So now what's the point of having an abstract class? That's the first question. Why? Why do we need an abstract class, or what does an abstract class do? There might be many questions, right? So first of all, the thing is, for example, I'll just give you a simple scenario. Okay, let's consider the scenario of graphic objects, all those square, circle, rhombus, trapezium, parallelogram, rectangle, all those shapes or all those polygons. So the thing is, if you list all those things, for example, let's just write circle, square, rectangle, fine. So now, if I give you a task of, just take a paper, again, just hypothetically, take a paper, and if I ask you to write similarities of these three shapes and differences among these three shapes, you'll definitely have some points to write about, right? Similarities as well as differences. What would be the similarities? What would be the similarities? Number of straight lines or something like that. Just giving you variables. Like all those three shapes require, exactly, all those three shapes will require some kind of straight line. For example, circle, 0, square, 4, rectangle, 4. Just to give you an idea, again, it might be silly, but what I'm trying to say is it will have certain similarities, right? All these 4. We're not bothered about similarities. I want to consider what are the differences between those three objects. What are the different things? Which thing is actually different among those three things? One I can tell is exactly area. How you calculate the area. Each figure it's different for each shape or figure, right? So now what I want to do is I want to write a class. Okay, I want to write a class. See, I want to write a class shape. Okay, I want to write a class shape, and then all the similarities as well as all the differences, all the variables methods, all the similar, everything I've written inside the class shape. Now what I'll do is I'll have class circle, class square, class rectangle. 3 classes extend this class shape just so you reuse the code. Okay. So now what is the problem? The problem, for example, let's assume in the class shape I've also written the method to calculate the area. Okay. So now then I have made these 3 classes implement this class shape. So now what's the problem? The problem is you have provided, because you are implementing area method here, all the 3 polygons or all the 3 shapes will calculate the area based on this definition, right? If you call circle, so for example, circle object is C, square object is S, rectangle object is S. So if you call C dot area, then whatever definition you gave, the area of the circle will calculate it in that way. Because why? Because all 3 classes are sharing the same way of calculating the area, or you can also say all 3 classes are sharing the same formula for calculating the area, which is just mathematically wrong, because we know calculating areas of these 3 squares are different, right? So now what do you want to do? What I want to do is I do not want to include area method areas definition here. I don't want to include that. I want this thing to be left upon these 3 classes. Okay, everything else can be shared, but I don't want area to be defined here. Okay, what do I mean by defined or implemented? When I say a method is being implemented, what do I mean? When I open the bracket and close the bracket and write some kind of code, then I mean that this inside this brace is nothing but the implementation of this method area. Okay, just to make sure my terminology. So I don't want the implementation of area to be done in the class shape, because implementation of area is different for circle, square, and rectangle. So I just want to leave this implementation part of area to these 3 different classes. So how do I do that? First thing is I should not provide class. I should just end it. This is how you do it. So let's try and write a simple program, and let's see how it actually works. This is interesting, guys. See. So I have a class shape, right? Yeah, I have a class shape. Okay. And then yeah, forget about all the similarities. We are actually concerned about area. So let's just take that one instance. So what I want to do is I calculate the area. Okay, fine. Let me just okay, this shows error because I have to return something. Fine. Now what I'll do is I'll have a class square and I'll have a class circle, right? So now this class square will extend shape and this class circle will extend shape because all these are nothing but by default shapes, right? So that is what inheritance relationship says. Square is a shape, circle is a shape. So it's logically correct that you create an easy relationship between those two classes. But what happens if I create an easy relationship in this way? What happens is whatever logic I say, for example, I write return a cross or A into A. Okay? Right? You know what happens is even the squared area will be the same thing, return A into A, and then circles area will also return A into A, but the circle area is A into A, it's not, right? So what I want to do is I don't want to implement area method right now. So I'll just delete. This is nothing but implementation part, guys, this curly braces. Everything inside these braces comes under implementation. So I don't want to implement this area method. So I just erase it and just I put semicolon. So this is called as a method without any implementation. So why does it show an error to me? Because the compiler doesn't know what you're trying to do. It doesn't know because you just, all it knows is once you have a method, you have curly braces. It sees that why are there no braces here? So you have to tell the compiler to relax because you actually want to do this. This is not a mistake. You actually want to do this. How you say that to a compiler? By saying that this is an abstract method. That means I don't want this method to implement right now. I want this responsibility of implementing this method. I want to give that responsibility to its child classes. Okay, I don't want to do that. This is the way you tell the compiler all that theory. Okay. So now, what are these two errors? The thing is, the condition is whenever a class has an abstract method, that class must also say an abstract class. Because what happens is the compiler or the JVM or the JRE comes inside this class, it just wonders why is there an abstract method. So it just before it kind of comes as a surprise to the JVM. So beforehand, you should say, before even entering into the class, you should alert the JVM that, hey, you know what, there is going to be an abstract method in the class, so don't worry, just relax. So you say that again by again writing abstract class, right? Is this fine now? So this is one condition about an abstract class. If there is an abstract method in a class, you have to declare the class itself as abstract. Now, is the other way necessary? For example, if a class is an abstract, that means there is an abstract method in the class. Is that necessary? It's not. See, for example, it's fine. No, why does it show the error? What? No. No, but the abstract class can, yeah, an abstract class sorry, it's the other way around. Again, I'll tell you what this is. I'll tell you what this is because it can also have default methods. Yeah. The thing is, if I'm telling you a class is an abstract, that means whether this class only has abstract methods? No, it can also have non-abstract methods as well. I'll write non-abstract methods in a while, but let's finish this part. Okay, you understood why I wrote the abstract, right? Because I don't want to provide the implementation of area. I have declared this method as abstract. And because there is an abstract method in the class itself should be named as abstract class. So when I say that class is an abstract, that means there is an abstract method in a class. Yeah, that's all it means. There's no other definition. Exactly, that is what it means. When you're basically alerting JRE or JVM saying that when you're entering into the class, there's a good chance of you seeing an abstract method in there. Right? Now you're trying to extend this class extends shape and then extends shape. Now the error is the other condition of an abstract class is if there's any class X, Y, or Z that is extending an abstract class, then this class should implement all the abstract methods. Okay, that is one requirement. So whichever class extends an abstract class, it should provide implementation of all the abstract methods. So you can just right click here or you can write manually. Let me just do it here, add unimplemented methods, and here also add unimplemented methods. Okay, so let's do one thing. Let's just have a variable here inside, okay, and then a constructor which takes us s.s equal to s, okay, and then since it's a square, what is the area of the square? Side square, side into side, right? So I'm done with this. Now let's have a display method. So let's just not have a display method because it actually returns, so we can just print it out directly. So yeah, this is the implementation of square. Now let's do the same thing in circle. Let's have a variable or a field that stores the radius and r. Okay, so good idea to store double. Area takes integer. You can take, but I've already said that it's taking an integer, so I don't want to change that. Yeah. I'm sorry, my bad. This is already a double area. I'm trying to do NTR. It's wrong. Anyways, so for this circle class, I'll have one more variable to store radius, fine, and then a constructor to store radius, and then just an empty constructor, circle, right? And then let's calculate the area of a circle. What's an area of a circle? Pi r square, right? So again, you have already predefined class math. So I think you asked a question is how do I have to know what the method? So you the thing is you just write the math class, and then the ID will give you all the powers and everything that is in there. So right now you have to just use pi, right? Pi. So I just said that all the constants in Java, their naming convention is just make those things as what? All capital letters. So pi, you can say that it is a constant variable. Okay. So math pi, this is pi value, and then what you want to do is r into r. That is what you want to do. Or you also have another function, this math dot power or something. So again, yeah, math dot pow is there in there. Anyways, let's just put it pi r square. Okay. So now I have two classes which are implementing an abstract, which are extending an abstract class, right? So now let's create an object of this class. What I want to do is I can do shape, right? This is the first class, right, which has the area method, because I want to calculate the area method. So I want to create an object of class shape. Let's see if I can do that. Shape equal to new. Why is it throwing an error here? Because the rule is, the first condition is, again, you cannot create an object of an abstract class. You cannot instantiate an abstract class. This was asked in an interview right here in this consultancy to someone. The question was, why cannot you instantiate an abstract class? I cannot instantiate an abstract class? Because the reason is, see, if it was allowed to create an object of an abstract class, then using shape, if I would have called this area, then what would have happened? Because this is an abstract method, it would have, the program would have just broke down, right? So the reason is you cannot instantiate an abstract class because there might be abstract methods. So if you call those
you input.
oh, good one. Area into area. So yeah, I've created a scanner invert. Now what I want to do is I want to ask user which shape area you want to calculate. If you want to calculate for circle, then circle, or if you want to calculate the area of square, then it's square. So now what I'll do is I'll take variable and I'll say if choice is equal to 1, then shape, see what I'm trying to do here, equal to new circle and then 5. Oh, this comes from C++. No, just to give you an idea, Mr. Swain, just showing this thing. This is what I actually do. This is for academic purposes, C++. This is why I'm writing printf and all that kind of thing. So yeah, okay, so I'm asking user whether to calculate the area of a circle or a square, and I'm taking that choice and that option input.next end, right? Whatever the user entered, 1 or 2, I'm taking that in choice, and I'm saying if choice was 1, then I want to point shape equal to new circle. Do you see what I'm trying to do? This, don't get confused. It's just like this. When I say int x equal to 5, right? This is how it's done, right? Shape equal to new shape. This is how we used to do. But what I'm doing here is I'm saying just int x, and then later on I'm saying x equal to 5. It's just the same thing. Don't get confused. This is again nothing but virtual binding. This is also polymorphism. What happens is, I'll show you in a minute what this thing is. Okay, if the user selected 1, then I point shape to a circle object. Else, I point shape to a square object. Let's pass aside as 4. Now I want to calculate the area, right? So I'll say area, and then I'll use the shape object and then call area. What is this?
Excuse me, sir.
Yeah.
I have a quick question here. Here we are assigning circle to the shape, right? Circle, or depending on the input value, we are assigning either circle or square to the shape, right? Object.
Yeah.
Usually we cannot assign one type of object to the another object, but here we are doing that because it is abstraction. Because if it is class, if A is for example for example, here circle is a different class and shape is a different class.
Yep.
We are trying to assign circle object to the shape object. Can we do that, like can we assign a different kind of object to another type of object?
Exactly. This is not an object. Right now, shape is not an object. What you are saying is shape is just a variable of type shape. But when I said, see, why am I able to do this is because the two actually share a relationship. That's the only reason I'm able to do this. What is this thing? Circle is extending shape, right? Do you agree that? Circle is extending shape. So that means circle is a shape. That is how you read it.
Oh,
So that is what you're doing. So this is
okay.
nothing but circle is a shape. So basically this circle object what you're getting is being pointed by shape. So
So
when you are
have inheritance. Yeah. Oh, okay.
Exactly, it's an inheritance concept. And one more question is, when I call shape.area, you should have asked which area, this area or the circle's area. See, shape, and then depending upon the user's choice, I'm trying to point shape to circle or to square. So now when I'm saying shape.area, which area will be called? So guys, remember, this is really, really important, and not a lot of people know this. The actual thing it works is, when you're trying to run the program or when JVM comes across these kind of statements, the method to which, see, the thing is, the area is being called, right? So which area should be called? It depends upon exactly the type. It doesn't depend upon the type of variable shape is, but it depends upon the type of object that shape is. Okay, see, this difference. Shape is of type shape abstract class, but it points to circle. Okay, here also shape is of type shape, but it points to square. So when I say shape.area, it doesn't look at this thing. It doesn't go, okay, shape is of type shape, so I should call area of the shape abstract class. It doesn't do that. It will check where shape is pointing to. In this case, if I've selected one, shape will be pointing to circle. So the circle's area method will be called. Okay, let's verify that if it actually works or not. Let's see if that works. Are there any errors? Abstract plus shape abstract double area and yeah. So let's try and check. What are the errors? Oh, yeah, this program works fine, right? This is the problem, method overloading in the previous file. Again, this entire thing is one project, right? So because there's an error in method overloading this file, let's just remove this file altogether and then see. Yeah, see, I'm entering 2 squares, so the radius of side pass was 4, so area of square is nothing but 16. Any questions about this? See, guys, I'll just go over this program once again. I'm writing a class shape. Okay, I'm writing a class shape. So I'll write all the similar things that, I'll write all the similarities that a square class has, all the similarities that a circle class has, and then I'll make those 2 classes extend those things. In the mean process, what happened was I also gave the implementation of the method, area method, right? So now what happened was this area method was also inherited in the class square and in the class circle. So now even the square and the circle, what it means when I'm doing this, what it means is the square and circle both are calculating area based on one formula, which is not right mathematically. They both have their different formulas of calculating. So in that sense, if there's a scenario where you don't want something to be implemented right away, but you want that responsibility of a method being implemented to leave it to child classes or subclasses, then you declare those methods as abstract. Okay, so you don't just provide the implementation, you just end it. So basically what you're saying is, I'm not sure how I should calculate the area as of this point because area of square might be different, area of circle might be different, so you're not sure. So you're just ending the definition by just putting the semicolon. So it doesn't know what this thing is, so you have to specify that. Don't worry, it's called an abstract method, so relax. That is what you're doing by writing an abstract. So once you write an abstract, the class must be also set that the class itself is an abstract. Okay, this is how it works. Now I've got 2 classes that are extending shape. So the rule is, whichever class extends an abstract class, it should provide the implementation of all the abstract methods. Even if there are 100 abstract methods, you should provide the user which area to calculate, and of type integer. Shape is a variable of type shape. So this line shape.area, this call doesn't depend on the type of variable shape is. It doesn't depend on the type of variable shape is. It depends on where shape is pointing to or which object it is pointing to. Which object is it pointing to? Circle or square. So that is how area of circle or square is being calculated depending upon the choice that we have set. Okay, again, just write this program once again. You'll understand what I'm going to do here. If you have any doubts, or you can ask me in the next class. So this is how abstract class. Again, there's a lot of theory about abstract class, so I please suggest you to go and read some. So at least go into Java T-pointer tutorials point, and there's a lot of theory of what you can do. And one more thing I want to say about abstract classes, you can an abstract class, see, once you have declared an abstract class, can this class have normal functionality like normal methods, constructors, normal variables? Can an abstract class have those things? It can. See, just to give you an example, shape color, let's have a string color, okay? So then I'll have constructor shape, string C, and then what I'll do is I'll assign that color, and I'll also have an empty constructor just in case. I'll have an empty constructor. And what I'm trying to do is, once I have an empty constructor here, let me just do this. See, as I said, an abstract class can also have an abstract method and non-abstract methods, right? Just like that. See, I have two constructors here, and let's write a normal method. As of now, this class only has an abstract method, right? So let's just write a normal method. Display, and then what I'm trying to do is I just print the color of the shape. So again, you can always call these methods using these display. Again, if you want to call this method, you can just say super display and all those, which we have seen in inheritance, right? How do you call methods or variables belonging to a super class using the super keyword? So you can just do all kind of stuff. And one more thing, one more question they usually ask you is, this is an abstract class, right? And I've already said you cannot instantiate an abstract class. I've given you the reason for that, right? So now you cannot instantiate an abstract class, but what's the point of having a constructor if you cannot instantiate? When does a constructor gets called? I said the constructor gets called only once in its entire lifetime, when? During the instantiation of an object. So if we are not instantiating the class itself, then why do we need a constructor? Again, same thing. Even though you cannot instantiate the class shape, but you can instantiate these classes square, right? So inside square constructor, you can call the super constructors, right? Yeah. Super of anything. Exactly, just like that. So again, try all these permutations and combinations. There's just many possibilities with this. So this is one thing about abstract class. Again, there are too many rules, what you can do, what you cannot do, which I think most of them are listed here, but even in case I've missed anything, I'll probably do that in the next class or something. Yeah, so any questions about this abstract class? No questions? So yeah, there's one more point I want to say about an abstract class is, I've told you what abstraction is, right? You have to hide implementation of something. If you say that this class does something, what abstraction means, if by looking at a class, I should only be able to say what this class does, but I should not be able to say how it actually does it. But here, an abstract class allows abstract methods, which is fine because it doesn't say how I'm calculating area. It just says that I'm calculating area, which is abstraction. But an abstract class also allows non-abstract methods. So I can actually say how I can save it can display something, and I can also say how it displays something, right? I can see the implementation of it, right? So that is not abstraction. That is not what abstraction means. So that's the reason they say abstract class does not guarantee 100% abstraction. That is what it means. Abstract class does not guarantee 100% abstraction. And is there a way around to achieve 100% abstraction? I mean, just have an entity which just tells you what it does, but it won't tell you how it is done. Is there a way of achieving pure abstraction in Java? Yes, there is. How? That thing is called as an interface. You have something called as interface, which is similar to a class, but I'll tell you in the next class. We're already late. So anyways, I'll tell you how to achieve pure abstraction. And also one more catch about interface is until Java 7 or something, I'm not sure about the numbers, but yeah, I think it's 1.7 or something. Even with interface, you could have achieved pure abstraction, but with the latest release of Java, that is Java 8, you no more have pure abstraction even with an interface. So that means even in interface, you can actually have a non-abstract method. So again, we'll look what interface and all those things are in the next class, which is on Monday. Monday, right? Cool. So yeah, that's it, guys. If you have any questions, you can email me. I'll send you an assignment. So I think, as Pratap said, you might be having a quiz on Monday. So if you have any questions, too much questions, we can schedule a class on Saturday. Or it's fine, you can email me or whatever it is. So I'll send the recording. I think, did this session got recorded or not?